Hello again, this is Tim Lloyd from GMAT.cz, part of Gain Access in the Czech Republic in the heart of Europe. This particular video is going to explain a very simple formula, and it's how to calculate the interior angles of a polygon. Yes, indeedy. So imagine a polygon has n sides. Okay, so here we have 1, 2, 3, 4, a particular image with 5. Such flashcards, such information can be easily found on the internet, so I'm just going to go through this one. The formula is n minus 2, where n is the number of sides. You then multiply that by 180 to calculate the total interior angles of a polygon. We're going to do two questions on this video. The first question is a very simple one. There's a tabletop and it has 7 sides of a regular polygon. Okay. Approximately, what is the degree measure of all the internal angles? So 900 down to 130. Well, it's very simple. Here we go. We draw out, always draw out in geometry the information given in the question. So here we draw it out. A, B, C, D, E, F, G would be, for example, 7 vertices, and it's 7 minus 2, okay, times 180. You then divide that by 7, so it's 900 divided by 7 gives you 130. So in other words, the approximate, it doesn't have to be too precise here, size of one of the internal angles is 130. Answer choice E. Okay, here's a pretty difficult question in comparison to the previous one. Not too hard, but certainly a step up. In a 7-sided regular polygon with vertices labeled A through G, if a straight line were drawn from vertex A to vertex D, what would be the approximate, again notice the word approximate, difference in the degree measure of the total internal angles of the two portions created, ABCD, AGFED. Okay. Now I'm going to apply that information to the diagram, and as you can see we have two shapes here. The left hand side, I've drawn the line as indicated from the question, and what I then decided to do was actually draw the internal angles as lowercase letters of those vertices, A through G. You might also notice that on either side of the line we have two angles, obviously, at those two vertices A and D. The internal angle A2 and A1, and the internal angles D1 and D2. If they weren't split, it would just be A and D. Now if you need to pause and recap all that, go ahead. Okay, no problem at all. Step 2, calculate the degree measure of each internal angle label A through G. This is a logical first step. We apply the formula, and obviously it's the same solution as we got in that first example question at the beginning of the video. It's 7 minus 2 is 5, times 180 is 900 total. Divide by 7, and it's an approximation question, so each internal angle is approximately 130 degrees. So in all honesty, GMAT is a reasoning test. We expect you to know how to do math, but reasoning is very often a good way to go. So let's just apply a bit of logic. If we compare these two portions in two stages, because the larger portion has G, F, and E as complete angles, and the right portion, the smaller one, only has B and C, we can immediately deduce that there is at least 130 degrees difference between the two sides. Again, pause the video if you need to think about that or do some scratch work. We can therefore eliminate answer choice E for definite and probably D. If you think about it logically, as I've said before, we're going to have a difference which is larger than 130. So again, D's gone in my opinion straight away. Now the key thing here is that the tricky split is to see that A1 is larger than A2 and D1 is larger than D2. And I'm going to prove that to you now so we can finalize this question. If you were to draw a line to bisect, that means two equal parts, the shape from A to a new point Z, which is halfway between E and D, okay, you have, as we say, bisected the whole septagon. Hence, angle A would be bisected itself, okay, creating two new equal angles. So in other words, at this point, A1 and A2 are equal because they're bisected and approximately 65 degrees. Next, if you just imagine we slowly close the gap between AZ or AZ and DA. So that AD, so basically it just falls down and lies on top of AD. Well, angle A1 gradually increases and therefore A2 decreases. That implies that D1 and D2 also share the same relationship. So let's put this all together. This is the final step. We know that portion ADEFG is larger than portion ABCD. We've calculated the difference between the two interior angles total of the two portions is the one extra 130 degree complete angle. Okay, so we can, as I said before, we eliminated D and E. We also know that the degree measure of angle A1 has to be slightly larger than half, or in other words slightly larger than 65, okay, and that A2 thus is slightly smaller than half, slightly smaller than 65. Since angle A is approximately 130 degrees, okay, answer choice A and B are just way too large, because we're just going to be adding something which is the difference between an angle which is slightly larger than 65 and an angle which is slightly smaller than 65 degrees, okay. So as I said, A, B, D and E are all gone. The only viable option is C. Please remember that since this is an approximation question, as you'll get on the GMAT, you do not need to be too precise. So I hope you found that video useful. There are many such questions in the GMAT itself, and you can find other explanations and other tricks and tips on our YouTube channel. Gain Access also has channels for ACT, SAT and other such tests. Thank you and see you soon.